Now we are going to see the frequency response plots. Frequency response analysis of control system can be carried out either analytically or graphically. By two ways, we can uh, various graphical techniques available for frequency responses analysis are first one Bode plot, second one polar plot, or another name of polar plot is Nyquist plot, next Nicholas plot, next M and N circles, then Nicholas chart. Okay, these are the types of graphical techniques. The various graphic techniques available are first one Bode plot, second one polar plot. Another name of polar plot is Nyquist plot, then Nicholas plot, then M and N circles, and Nicholas chart. So these are the various graphical techniques available to find the frequency response. Okay. So what is frequency response? Varying the frequency and seeing what is happening in the output. It is nothing called frequency response. This Bode plot and polar plot, they are usually drawn for open loop systems. So we should be careful. This Bode plot and polar plot, they are usually drawn for open loop system. So we are using it only for open loop system and not for closed loop system. This Bode plot and polar plot are used for open loop system. Frequency response plots are used to determine frequency domain specification. So we have studied some frequency domain specifications. So in order to find that frequency domain specification, this frequency response plots are used. Okay. To study the stability of the system. So we can check by using this frequency response plot, we can check whether the system is stable or unstable or marginally stable. Okay, so such things we can find by using frequency response plots, and we can adjust the gain of the system. We can adjust the gain of the system to satisfy the desired specification. So sometimes it is necessary to design a system for some desired specification. So if there is any problem in the gain, then you can adjust the gain by using this frequency response plots. After getting the frequency response plot, from that frequency response, from the knowledge getting from the frequency response plot, you can adjust the gain. You can adjust the gain of the system to satisfy the desired specification. Okay, first we are going to study Bode plot. What Bode plot is a frequency response plot. What is Bode plot? It is a frequency response plot of the sinusoidal transfer function. What is sinusoidal transfer function? In the place of S, you are substituting in the place of S, if you are substituting j omega, the transfer function will become a sinusoidal transfer function. Okay, so in the place of S, if you are substituting j omega, it will become sinusoidal transfer function. Actually, the Bode plot consists of two graphs. How many graphs the Bode plot will be having? It is having two graphs. One is magnitude plot and the another one is place plot. First one is magnitude plot. Magnitude plot is nothing but it is a plot between the transfer function versus log omega. Next one is phase plot. It is nothing but a plot between phase angle of transfer function and log omega. So what is magnitude plot? Magnitude plot is nothing but the magnitude of sinusoidal transfer function versus log omega. And next one is phase plot. It is nothing but phase of sinusoidal transfer function versus log omega. So you are having two plots. One is magnitude plot. One is magnitude plot. One is magnitude plot. And the second one is phase plot. There are two plots available. One is magnitude plot. The second one is phase plot. Magnitude plot is nothing but it is magnitude of transfer function versus log omega. Next one, phase angle versus log omega. So there are what is Bode plot? Bode plot is a frequency response plot of my sinusoidal transfer function. And there are two types of plot. One is magnitude plot, another one is phase plot. Bode plot can be drawn for both open loop and closed loop transfer function, but mostly it will be drawn for open loop transfer function, but it can be drawn for both the open loop as well as closed loop transfer function. Bode plot can be drawn for open loop and closed loop transfer function, but usually it is drawn only for open loop. Okay, it should be clear. This Bode plot can be drawn for both open loop as well as closed loop transfer function. Okay, so this, but it is usually drawn for open loop. So the standard representation of logarithmic magnitude of open loop transfer function is 20 log g omega. This is nothing but the standard representation of magnitude. Okay, this is the standard representation of magnitude of open loop transfer function. Okay, so open loop transfer function is nothing but g of s. So in the place of s, if you put j omega, then you will get the sinusoidal transfer function. Okay, so in this, the standard representation of this g of j omega is nothing but 20 log g of j omega. Okay, so the unit of this magnitude is in decibel. You should be careful. The unit of this magnitude is in decibel. Actually, we will be drawing this Bode plot in a semi-log paper or semi-log graph sheet, semi-log sheet. Okay, and you'll be using log scale or abscissa for frequency. That is, x-axis is for frequency. So we will be drawing it in a semi-log sheet. In the semi-log sheet, the x-axis is in frequency. The x-axis is a log scale. Okay, x-axis is a log scale, and in the log scale, you will be representing the frequency. And linear scale, the y-axis is a linear scale. This is the linear scale or ordinate. Here we will be using for magnitude and phase. Okay, actually we will be drawing it in semi-log. X-axis is frequency. That is a logarithmic scale. This scale is log scale, and in y-axis you will be representing the magnitude. Y-axis will be representing the magnitude or phase. Okay, representing the magnitude or phase. This scale is linear scale. Linear scale. X-axis is X-axis is log scale and y-axis is linear scale. The advantage of Bode plot is multiplication of magnitudes can be the multiplication of magnitudes can be converted into addition. So this is important point. Magnitudes of multiplication can be converted into addition. The first advantage of Bode plot is multiplications of magnitudes can be converted into addition. Next one is a simple method for sketching an approximate log magnitude curve is available. Okay, so it is a simple method. This first advantage is here you can convert the multiplications into addition, and the second one is it is a simple method for sketching an approximate log magnitude curve. So it is a simple method for sketching a approximate log magnitude curve. Okay. Now we are considering a open loop transfer function. So this is a open loop transfer function, that is g of s is equal to k into 1 plus st1 divided by s into 1 plus st2 into 1 plus st3. So having this is a transfer function. Okay. Now here you are having, now we are converting this transfer function into sinusoidal transfer function. What is sinusoidal transfer function? In the place of s, if you substitute j omega, then it will become sinusoidal transfer function. What is sinusoidal transfer function? In the place of s, if you substitute j omega, in the place of s, you have substituted j omega. Here also you have substituted j omega. Here also you have substituted j omega, j omega, j omega. So in the place of s, you are substituting j omega, then it will become a sinusoidal transfer function. Okay, so when analyzing this transfer function, you understand that you are having 1 0. The thing what is having in your numerator is called 0. This is 0. These are poles. So you are having 1 0. You are having 1 0 and poles. How many poles you are having? You are having 3 poles. This is one pole, a pole at origin, next second pole, third pole. So this question you are having 3 poles and 1 zeros. What you are having? You are having 1 zeros and 3 poles. You are having 3 poles and 1 zeros. So now we are finding the magnitude and phase. So for example, if you are having one complex number x plus iy, its magnitude is nothing but root of x square plus y square. Okay. So if you are having a complex number, and if its magnitude, if you are having a complex number x plus iy, then its magnitude is nothing but root of x square plus y square. Okay, then its angle is nothing but its angle phase is nothing but tan inverse y by x. Okay, tan inverse of imaginary part divided by real part. Similarly, here they have found out they have calculated the phase and calculated the phase and angle. So for this one, the angle is root of